So when creating these slides, I thought this was going to be like HD. It's not. It feels like I'm in a 8-bit Mario game. But okay, you have to do with it. So welcome to this. Probably is this the final session between this and beer, or?
Yeah, so get on with it.
Okay. I have 45 minutes and 92 slides, so you have to keep up with it. Right, so I work at a partner, and this is quite unnormal for a partner, but I do, some people ask me to put a disclaimer there, because I'm gonna show some things that are not GA yet. I've been working with both NVIDIA as well as Intel to work on their latest GPU offerings and see how certain applications work within those offerings and how to basically improve or get the most or the best user experience out of the stuff we do. So whatever I tell you, don't buy because I tell you. Test it yourself and do proof of concepts. Then you know for sure that it will work. So the stuff that I'm gonna show is not always working with GA drivers. I use beta drivers to get the most out of the stuff that I showed. So be aware of that. So my name is Johan van Amersfoort. I'm a nerd and I'm part of VMUG. I'm a VMUG leader in the Netherlands. I work for ITQ. We're one of the sponsors here. And within ITQ, I'm responsible for everything hybrid workforce. So I live, breathe, eat EUC and GPUs and stuff like that. So I'm also a podcast host of 2 podcasts. The first one is just interesting for the Dutch among us, and I guess that's just Frank here. But the second one, Unexplored Territory, is a podcast I create with Frank Denneman and Duncan Epping, bi-weekly podcast on everything VMware. And we love creating it. So if you haven't seen it or listened to it yet, please do so. So I wrote a couple of books on the exact topic of today, how to get the best experience out of your VDI platform. The first book was purely about designing. You can download it for free. There's going to be a link later on in the presentation. The second one is about the use cases that we built, including gaming. Like gaming is a use case we saw at customers, and that's what this session is mostly going to be about. So I don't really have an agenda, but I'm going to talk about 3 topics: hardware, APIs and codecs, and software. This is high. Yeah. So first question, who uses GPUs? Oh, quite some hands. NVIDIA GPUs? AMD GPUs? Ooh, in like for business stuff or purely gaming? R&D. R&D. Ah, nice. Is this under NDA? Yes. Ah, nice. You heard it here first. Oh, and there should be a second question. Third question. Intel GPUs. No hands. Okay, interesting. So is it purely for graphical acceleration? Okay, so VDI, computational acceleration, so deep learning, AI stuff, okay? Okay, good to know. So let's talk about GPUs. Who recognizes this GPU? Okay, a couple of hands. Which one is it?
It's the 3DFX.
Yeah, which one?
Yeah, I'm blanking. It says 3DFX. I can do that.
3DFX, yeah, well, that was the brand.
It's a Voodoo one.
Voodoo 1, yeah, it's indeed a Voodoo 1. Technically, this is not a GPU, but an accelerator. You basically daisy chained it to your PCI VGA card and it accelerated stuff. But you didn't only have to use the card, it was necessary to use an API as well. Because without the Glide API, you basically cannot use the card. So the card plus the API made applications look awesome. Who recognizes this game? Which one? No. Which one? 2. Quake 2. Yes, this is Quake 2. So this is Quake 2 running on a CPU. This is Quake 2 running on the Voodoo 1 with 4 MB of video RAM. And there are 2 main differences, and you cannot see it in a picture, obviously, but frame rate increased. So from a frame rate perspective, the Voodoo card had a huge impact. But also, look at the textures here. It's a lot smoother, right?
Ray tracing.
What?
Ray tracing.
No, this was not ray tracing.
Almost.
This is ray tracing. Right, so take the same application from late 90s, use a modern API and a modern GPU, and this is what you get. Same game, same binary, same everything, but a better user experience. I'm going to show this in a demo in a bit. Right, so this is all cool, gaming and stuff, but from a business perspective, how interesting is this? And question here seriously is, do you need a GPU in business? What do you think? Well, short answer, yes. And I did not make that up. That's what Microsoft made up. So this is the prerequisites of Windows 11. And it says that it requires a graphics card. Windows 10, same thing. This is the short answer. Long answer, this is the first demo. This is a huge virtual desktop. This is a virtual desktop with an NVIDIA graphics card. Could be any card. In this case, it's virtualized, but it doesn't really matter. What's really important is that the column called type has C plus G, and you see different types of processes running that are linked or tied to the GPU and marked with C plus G. One of them, for instance, is explorer.exe or text input host.exe or search app.exe. Those are all individual processes which are part of Windows, which are accelerated using a GPU. So native processes in the Windows OS, and this is Windows 10, are running on a GPU. So it's not just those graphical apps, it's also those native services inside the in the Windows OS. So let's dive a little bit into what a GPU is. I talked about the Voodoo card, which technically wasn't the GPU. This one is. So which one is it? Kind of same time frame. There's a brand somewhere there. No, it's the Diamond Fiber 550, and it was not the very first GPU, but it was one of the first ones that showed a true difference with certain APIs. It had 16 MB of SDRAM, 2 cores, 2 whole cores, over 100 megahertz, no encoder, really important to know. And if you look at the difference between a GPU and a CPU, we're not gonna dive a lot deeper into this, but I'm gonna quickly go over it. CPU has a couple of cores, really complex ones, can basically calculate anything. A GPU has thousands of cores, not that complex, can do a couple of things really good and really fast and in parallel, and that's really important to know. Now, if you look at nowadays types of GPUs, they have what we call a compute engine, which consists out of different types of cores. So you have those compute cores, you have tensor cores, and ray tracing cores. And these cores are used by different APIs in different ways and try to get the best result from a certain calculation. Now, if you take a GPU package, it does not only contain those cores, but also video memory, or frame buffer as we call it. Quite often DDR6, very fast memory, much faster than RAM, if you will. Now, certain packages like or certain cards, like the ones from NVIDIA, new cards from Intel as well, have multiple of these GPUs on a single card. So this is basically the hardware layout of an A16 from NVIDIA, which basically has 4 different individual GPUs on a single card. Hardware is awesome, but obviously you need APIs to use that hardware. So there are different types of APIs that you could use with the card, and these are the most common ones. So the above one, they're supposed to be green, are the ones used for visual acceleration. So OpenGL is one of the most commonly used ones next to Direct3D, and Falcon is commonly used for gaming. Now the below ones, CUDA, OpenCL, and OneAPI are computational APIs. Not entirely true. One API is also used for certain visual aspects, but it's proprietary to Intel hardware only. Might change in the near future. So who remember this thing? What is it? Yes, it's an Apex card. So early GPUs, like the first grid ones and the diamond ones, don't have encoder hardware on it. Now, in order to offload certain encoding tasks to a GPU as well, you needed to have additional hardware, such as an Apex card from PC over IP. Now, the one thing that modern GPUs do have is what we call a media engine. And a media engine consists out of encoders and decoders. And if you take like the hardware layout with those different types of cores, frame buffer, and media engines, you need those APIs, graphical, computational, and codecs in order to fully benefit from the hardware that you have. Now, when looking at these codecs, we basically have three different types of codecs. And looking back at the visual, you can see that there are three different codecs there, but there are more codecs supported by Horizon. And the reason why they're not there is because these codecs, the BLAST one and the PNG one, cannot be offloaded to hardware. So they're CPU encoded only. And that's great, but when looking at high fidelity use cases, they're not great. They're mostly used for office use cases, for use cases that don't have that many changes on screen. So they don't have to be encoded that much. Right, so H.264 is one of the most commonly used codecs for both high fidelity use cases, but mostly use cases in general. And it has the potential of being offloaded to a GPU. So it doesn't have to be, but it can be. And HEVC or H.265 and AV1, the latest addition to the codecs that Horizon supports, must be offloaded to a GPU. And we'll dive into that later on. Now, it's awesome that we have this, but obviously you need a virtual machine to run specific things on to use the APIs to consume the hardware that you have. So within different types of apps, you have different types of aspects that could use a GPU. So that could be specific apps like a CAD app that fully offload to a GPU and benefit from all the APIs. You could have specific functions within an app. Take an EMR application for healthcare. So they might have a Google Earth plugin that does use a GPU, but the rest of the application doesn't. So you still need access to the APIs. And visual OS functions, like if you take Arrow, which was introduced, I think, at Vista. Arrow used a GPU to basically render everything that happened in the OS. So certain functions require that GPU as well. And there's also different types of computational functions and apps. Frank told a lot about deep learning apps. Well, take Copilot, for instance, that might require a GPU as well. So there are different types of functions that use the computational aspects. And if you look at mainstream apps that we now use in our business, like Teams or Zoom, they require codecs. And codecs can be offloaded to GPUs as well. Right. Now let's look at virtualization of GPUs. And let me quickly get my water first. Right, so there are different types of virtualization options within the vSphere platform. So what you basically want to do is offload or share basically the hardware that you have with a virtual machine. So let's take the hardware. And the first flavor there is, and this is basically also the oldest that we have, is direct pass-through. So you take a GPU, you pass it through to a virtual machine, and bam, you have access to the virtual machine. Second one, who uses vGPU? Okay. basically share one GPU with multiple virtual machines with a scheduler in the middle, and the scheduler takes care of the access of a virtual machine to the GPU. Frame buffer, so video memory is directly allocated, but GPU cycles, calculation cycles, are scheduled through the scheduler, basically like a hypervisor works. Then there's SRIOV. Who uses this in combination with GPUs? No hands. Frank? No? Not with like NDA options? Interesting. Right, so what is interesting is that Intel, with their newest offerings, do use SRIOV. So you basically virtualize access to a part of a GPU. In the telco space, it's quite normal to use SRIOV to virtualize access to a network card. Intel does the same with their GPU offerings. And finally, I haven't found a use case yet, but NVIDIA, since the latest architecture, now also supports SRIOV in combination with virtual GPU. So you get, basically, they think the best of both worlds. Okay, so let's dive into remoting protocols. Blast Extreme is what we're going to dive actually into, because Peace over IP still exists, is still being developed. It's a great protocol and nowadays owned by HPE, but VMware doesn't use it anymore. No, doesn't innovate in it anymore. So there's still support for it for quite a while. I think the end of support is now announced for end of next year or the year after. But all new features are being put in Blast Extreme. Now, who is experienced with CloudXR? Who does not know what CloudXR is? Ah, okay. CloudXR is owned by NVIDIA, and it's a remoting protocol primarily used for VR offloading or VR remoting. So you basically have a VR headset, like an Oculus Quest, and you use a specific remoting protocol like CloudXR to get remote access to the applications. And CloudXR supports more than 60 frames per second. If you have just 60 frames per second, you will get nauseous while having the headset on and remoting the application to the headset. We're not going to dive into any of these three ladder connection protocols. We're going to dive into Blast Extreme. So why Blast Extreme over PCI over IP and RDP? Well, it's owned by VMware. It's based on VNC, which means it's, I won't say open source, but it's based on a universal standard that a lot of remoting protocols are using as well. It supports all major codecs. So the ones you just saw are the most commonly used in the market, and it all supports them. And it's very latency tolerant. And you'll hopefully, fingers crossed, gonna see that real life because the latency here is very high. And the Wi-Fi sucks. So it's a perfect use case to do a real life demo. So it does support high fidelity use cases, and it's highly optimizable, which means that I work with companies on oil and drilling rigs in the middle of the ocean using a satellite connection with 150 to 200 milliseconds of latency, and still got a relatively okay user experience. So yeah, definitely good to use there. So what can we optimize? It's quality, compression, bitrate, frame rate, really important, and I'll tell you in a bit what the relation is there. It is latency tolerance, and we can adjust that as well. And the channel usage, quite often overlooked, but configuring the wrong channels within Blast Extreme will let you end up in a shitstorm, a true one. So let's dive into a combination of compression, quality, etc., and bitrate. So who is familiar with the term quantization? Okay, that's good. So VNC as a platform uses quantization to basically determine what the best compression will be based on the bitrate that you configure. It's quite simple. You configure a number, and based on that number, it automatically generates compression and makes sure that that all the packets that you send over the network are compressed based on the bandwidth that you have. And they do that on a scale of 10 to 51. I have no clue why 10 to 51, but 10 is the highest, 51 is the lowest. But yeah, if you configure it, the min QP, if you will, and we'll talk about that later on as well. If you configure that to 10, it means that you push it with the highest quality, with the lowest compression, but it also will consume the most bandwidth. So what you ideally want to do is find the best values for min QP and max QP, so it will compress the packets the best, if you will, but with the least decrease of quality. And that's what I'm going to show in a couple of demos. So we have two values that are important, min QP and max QP. Starting point, always a great starting point when you start tuning, set them to 10 and 26. By default, they're 10 and 36, which means that it automatically will generate more compression even if it's not necessary. So the frame size is important, especially with like if you use a 4K screen, it means that every single frame is 4 times the size of a full HD frame. Now imagine if you have a 4K frame with 60 frames per second, not compressed or hardly compressed. What will happen is that if a frame is 20 MB in size, so 20 megabytes, it will send 60 times those 20 MBs over a WAN connection to an endpoint. That might work, sure, but if your endpoint is a Raspberry Pi or a low-powered Chromebook, it won't work. So yeah, you need to work with the things that you have, but also make sure that you add the right compression and also limit the frames to what you need, not what you can. So 60 frames per second sounds really awesome, but the naked eye of an average person within a company cannot distinguish the difference between, for instance, 25 frames and 35 frames in a YouTube video. So don't configure it with 35, go with 25. They won't complain. And quantization is only used within these 3 codecs. So H.264, H.265, and AV1. Right, so we talked about those codecs. Use cases for those codecs are, and I talked about that already a little bit, low fidelity FPS use cases for software encoding and with BLAST and PNG. The difference between H.264 and H.265 is compression and quality of the images. And also really important, it's quite often overlooked and not talked about. But if you want to use H.265 and AV1, the actual endpoint, so in this case, for instance, a Mac, needs to support that as well. H.264 is one of the most commonly used codecs simply because a Raspberry Pi has decoding chips on it that support that. Every Windows OS, every modern CPU has instructions to run decoding of H.264. So that's why it's commonly used. If you want to configure it and you keep it default at the agent side, so at the virtual desktop side, this is basically what you need to do. And this is a Mac, but the only thing you need to configure is, am I gonna allow it or not? So if you disable the 4 that are right now marked and only have allow blast codec decoding on, you won't get that high quality end result within your virtual desktop session. So make sure to configure the codecs that you want and that you need to have decoded on the endpoint. Right, so I mentioned virtual channels a bit. Blast Extreme works with virtual channels, which means that we have a number of channels that are configured or set up, if you will, between the client and the agent. And the most important one is the remote experience channel. So it's basically the channel you use to view everything that you do. So if I start an application and interact with the application, all images that are frames that are being sent over through the VMware virtual channel, so VVC. Then there's a second channel. It's USB redirection. This could be the devil for your user experience. I'll explain in a bit why. Then there's MMR, multimedia redirection. Who uses that? Okay. And there's a load of peripheral channels. So take RTAV. So if you want to redirect a webcam, you use a dedicated RTAV channel. Scanner, same thing. So scanner redirection uses a Twain driver integrated in Horizon. So you basically redirect a compressed image through the connection, through the session. And all of these peripheral channels are compressed by default and are controlled in terms of bandwidth. So if you send something over the clipboard, a nice example, I have an image of 10 MB and I want to send it over from client to agent. It will be compressed, it will take a time, but eventually it will be pasted inside the virtual desktop. If you use a device that cannot be supported by any of these channels, your fallback scenario is USB redirection. But USB redirection is raw. It's not compressed, it's uncompressed. So if you take a device like a flash drive and configure it in such a way that it uses USB redirection instead of redirected drive mappings, it'll send all file interactions through USB to the agent, uncompressed, non-controlled in terms of bandwidth, and it could easily mean that you're trying to send 10 gigs a second of files to the agent. No one will be happy with that. So make sure that if you configure devices, add devices to your client, that you select the right channels to do so. And I'll show in a demo in a bit how to monitor those individual channels as well. So choose them wisely. The virtual channel, VMware virtual channel, and the peripheral channels are compressed by default. MMR is redirected, and like I mentioned, USB is uncompressed. So it's almost demo time. I selected a demo app, which is, and I already spoiled it a little bit, Quake 2. The question I always get is why? Well, it's not just because we can, well, it's also because we can, but games and apps have a lot of, if you compare them, they have a lot of similarities. Because they both could require a GPU, they both require a lot of RAM, they both require, in this case, a high clock speed. And if you take a look at like modern EMR applications or CAD applications or any type of complex app, development suites, most of them are single-threaded, which means they need a seriously high clock speed to work pretty well. And that's with Quake 2 as well. It requires, well, it takes all the CPU cycles it can of a single core. Now there are some differences. So applications burst GPU resources and CPU resources. So take CATIA, for instance. If you load a model and you try to turn around the model, it'll increase the required GPU cycles, so it'll take more GPU resources from the card, while games take all resources they can, and they use the resources while doing nothing. Perfect example is, for instance, F1 2020, any F1 sim racers? Okay, if you have like an F1 app, you open the GPU resources in the Windows performance the task monitor. If it doesn't do anything, you still see the GPU cycles, the GPU usage between 90 and 100%. So it claims everything there is. Games are simple to install, apps are not. Apps are, again, the devil. So there's a difference there's a lot of similarities between gamers and designers as well. So both hate latency. If you have, I don't know, a CAD designer again, and he or she moves a model, and there's a little bit of jitter, they start complaining with the service desk. If a gamer has latency, especially in a first-person shooters, they'll probably be killed before they can actually move. So both might use weird peripherals, like space mouses in CAD applications, and F1 simulators have weird steering wheels and stuff, and both just want stuff to work. So a couple of facts about games. Games are not built for VDI, so that makes them the ideal candidate to actually showcase that they can be virtualized. They will run with vGPU, but they're not built for vGPU. So vGPU was never built to run games. And it is kind of voodoo. So if you want to do this, use the right tools for the job. And that's what the first demo is about. So this is one of my favorite apps to basically test user experience. This is the WebGL Aquarium, and it's one of those badly written WebGL applications. What you can see here is simple, the performance monitor in Windows. If you open perfmon and you add a couple of metrics, you can automatically see dynamically what's happening. So the yellow one, for instance, is the decoder. As soon as I start playing a YouTube video, you can see the decoder automatically doing something. If we stop the video, you can see the decoder automatically dropping and not doing anything. Who uses YouTube videos to tweak or tune remoting protocols? Stop doing that. Because of this. So the decoder starts doing stuff. Your CPU needs to push frames to the GPU. So if you want to use a video, download the video and play it on the inside the virtual desktop instead. It gives you a clearer image. So you can see that as soon as we start to play stop the video again, it'll impact the GPU resources. Now, my next tool of choice, who knows RD Analyzer? Okay, so there's a free version of this tool. There's a paid version. The paid version costs, I think, like 20 euros a year. So there's hardly anything, but it shows kind of the same metrics and telemetry, but it shows even more. So it has a nice interface, and the paid version also lets you adjust some of the Blast Extreme metrics or configuration options. So stuff you can see here is like the bandwidth consumption is now roughly around 11 MB. And I'm going to show that in the next demo. Oh, I'm going to show it now actually. If we adjust the compression values to 15, so 15 is a high number, which means less compression. The bandwidth output now increases to 20 MB. So it's an immediate change to the bandwidth consumption because every frame is now less compressed. You also see something happening to the user experience because of that. Right, so let's look at an OpenGL app. And that is Quake 2. OpenGL API uses the vGPU, the virtual GPU. And you can see, well, frame rate is pretty awesome, pretty good-ish. On top, you can see the performance tracker within Horizon. So it comes with the Horizon agent. If you start it, and you click right button on the actual application, you can have a flat one that you can lock on top. Now, again, using this same application, but with a modern API, changes the user experience. This is running inside the same virtual desktop. And if we change the renderer within the application, by default it's set to OpenGL, but now we have set it to RTX. And I'm hoping, yesterday on a projector it didn't really show the real-time ray tracing. I'm hoping this is a better projector. Well, it's a movie theater, so what you'll see is a little bit of light. Yeah, you can see it right now. There's a little bit of light glares coming from above. No, you can hardly see it. What you can see now is the mirror, for instance, and all the glares coming out of the mirror are dynamically ray traced by the hardware. So there's no impact. There's a huge impact to the GPU, but there's hardly any impact to the CPU. Where are you? CPU used by the encoder. It's just 3%. So this is the benefit of that GPU. If you use the right APIs and offload the things that you need to those APIs, the APIs will send it to the GPU and save your CPU cycles. So let's do some live adjustments. And bear with me, I did the same thing yesterday, and yesterday the whole thing broke. And when I say break, it literally broke. So this is a live environment, my lab. You see this, oh, this is really sort of hard-ish. Okay, so the same application, and if we, anyone mind if I stand with my back towards you? If so, I'm sorry about that. Yeah. Can you catch me? Yeah. Okay, so there's, I'm going to show two things. First of all, this is again the remote desktop analyzer. So you can see those metrics in real time. It's currently set to 10 to 51, which means it is the full spectrum of compression that can occur. If I now change and look at the bandwidth output, so it's 4 or 5 MB. If I now change the compression to, for instance, 15, it dynamically changes the setting. That's mostly because purely because all of these settings are tied to the user area of the registry. So you don't have to be an admin to basically adjust these settings. You can automatically see what happens to the bandwidth, and this means that every frame is less compressed. So if you have those high fidelity use cases, for instance in a hospital or something else, and they need uncompressed images, this is the way to do it. Now I also configured high color accuracy, which means that there's a different viewage of the colors. HEVC does support this as well, and this has an impact to the CPU cycles of your endpoint or possible GPU if you have one. If you disable it, you'll probably don't see that much of a difference, but it does impact the endpoint. Well, you see a little bit, no, not really. It does impact my Mac. So an M1 has native decoding baked into the CPU and the GPU of the Mac. If you don't have that and you enable the high accuracy setting, immediately see that it impacts the decoding resources being used in the endpoint. Now there's a second way to configure it if you don't want to use a tool like this, and that's basically just a registry. So there's a couple of settings, and these are the default ones that you can adjust, and if I refresh them you can probably see that it has adjusted. Yeah, so it's 10 by 15. So if I set this back to 51 and adjust, for instance, the starting point to, I don't know, 41, you can automatically see what happens to the image, right? So it now forces compression to the bandwidth or to the individual frames, and as a result, you can see that it now consumes just roughly 1 MB. If I change the frame rate to even less, like 30 frames a second, it should reflect in a bit the bandwidth use as well. See what happens? So if you have those use cases with less bandwidth, with high latency, this is the way to start tweaking and tuning the user experience, the Blast Stream protocol, to get the most out of the situation that you have. Any questions so far?
Can this not be done automatically, that
Great question. So, question is, can you automatically do this or automatically adjust this? Not in the version that I'm showing that here, but yeah, let's continue in the slides. And it should make a little bit more sense. Are we back? Yes. Two useful resources you can download. Like I mentioned, the first book I wrote about VDI design for free, and it contains almost 65 pages full of stuff around remoting protocols and GPUs. It's a little bit outdated in terms of the types of GPUs that I talked about, but the principle is the exact same. There's a second guide, but it's also unfortunately outdated, which is the Blast Extreme Optimization Guide. That is the official guide from VMware that you could use to configure the user experience or to tweak it, but it does not contain AV1. Coming back to your question, so I haven't really talked about AV1, but what is it? It's the successor to VP9, and VP9 is the codec that YouTube uses used to use to encode and decode their video streams. So all of your TVs, if you have Netflix there or YouTube there, a YouTube app, they have that native VP9 decoding in the hardware. But there's a challenge with all of those, like VP9, HEVC, H.264, is that they're licensed. So they're owned by a company. They're not owned by, in this case, VMware or YouTube. So AV1 offers a better compression, better video quality, which is really important, and it's created by the Alliance for Open Media, which means it's fully open sourced. So there are a lot of companies contributing to the success of AV1, and I'll promise you this will be the next best remoting protocol of basically every company that does something with streaming. So it's open sourced and it's GA in 2306, but very buggy. So you could use it, but it's a thing. So how can you tune it? And that's basically the answer to your question. It is dynamically adjusted using 5 levels, and it uses similar compression or similar algorithm like the quantization algorithm, but it does that automatically, and it has 5 different steps for 5 different types of situations, varying from high quality, high bandwidth, low latency environments to high latency, low bandwidth, and it automatically adjusts the bandwidth according to the telemetry that it gets. How can I use it? Well, it does require hardware encoding and decoding. So you need an endpoint that has AV1 baked in. If you take a modern M1, which is relatively modern, right? It does not have AV1 decoding. So you cannot use AV1 with Apple devices yet. If you want to use it, for instance, with NVIDIA, you need an endpoint with an NVIDIA GPU or an Intel GPU to do so. So Intel end-to-end, Flex 140, Flex 170, Intel Max to an Intel discrete card or an Intel integrated card into your CPU. So all modern, I think 14th gen CPUs from Intel have this baked in. So Intel, NVIDIA end-to-end, and it should cross vendor work. So if you have an AV1 decoder capability in an endpoint with Intel chips or NVIDIA chips, you should be able to use, for instance, an NVIDIA GPU, and I think every, what's the H stands for again with NVIDIA? Hopper. Yeah, so all modern architectures from NVIDIA, starting from Hopper, include AV1 encoding in the hardware. So the media engine does support it. So you should be able to test it. But again, it works very buggy. I could show you a demo maybe tomorrow, if you're still here, where I ran an F1 simulator just because of well, it's awesome. And it automatically switched between AV1 and the blast codec without, I didn't do anything. So I opened up the game, I started driving, and as soon as I hit the steering wheel, I saw the encoder automatically switch, and you can see that using the Horizon Performance Tracker, and you see your user experience drop. Like it's hard to steer, frame rate is bad, compression kicks in. So it's I don't know, it's not ready yet. So honestly, I won't touch it. To conclude, Blast Extreme works out of the box. It does really work out of the box, but if you have those high fidelity use cases, those complex applications, it requires tweaking and tuning. I strongly believe that any high quality application could run inside a virtual desktop and you can get a great user experience. I truly believe that. And use tools like Perfmon, which is fully free, and RD Analyzer to optimize the UX. So are there any questions, or do you want to see any other stuff like in real life?
Maybe in relation to the notion of games being of one sort and applications being of others. I work in the architectural business and we see a push towards twin motion, N-scale. There's a lot of real-time engines relying on actually a good feedback, and it's difficult to virtualize, and you're depending on one computer having all the power. Do you see anything which relates to what you're talking about virtualization of such workstations?
Yes. Let's take that offline if that's okay. I'm working with a customer of which I cannot name the type of customer, but they're in the automotive space, and they have monster workstations now fully virtualized. And the only reason they virtualized the workstations was because of the security of their IP. And it's a very expensive platform, but it's, yeah, they can now, their designers can work from anywhere in the world while maintaining security. So it is possible, yeah. I saw a question, I think, there, yeah.
Do you have any opinion or recommendations in terms of hardware acceleration, enabling, disabling in browsers?
In browsers?
Yeah, like from Firefox, enabling or disabling hardware acceleration.
Okay, so if you have a GPU, enable it by default. Open up a browser with multiple tabs and keep the task manager in Windows open up with the GPU resources tab on. So what happens is you browse through the different tabs, you automatically see the GPU utilization increase, and that means that the browser automatically offload that. So who closes tabs? Who's not lying about that? Okay, interesting. That's a large number, by the way. So, but on average, people don't close tabs. And at customers, easily we see VDI sessions with browsers that have like 50 to 100 tabs open on a day. Seriously, I'm not kidding. If you don't have acceleration enabled, that's a shitstorm in terms of performance. So you definitely want to offload whatever can be offloaded to the GPU in that case.
That's what we see that the performance drops.
Really? Let's take that offline. Any final question before I get kicked off the podium? Okay, can you kick me off? No. Thanks, and enjoy the rest of the conference.